Okay, pre-cal, before we start getting into Unit 1D2 a graph of a function notes, let's quickly go over interval notation. Now, most of you, have seen this in Algebra 2 before, but it's always nice to just quickly review it since we use it so often. So find the domain and the range of each continuous function. So the domain are all the possible x values, right? So no matter how far I go to the right, and if I kept going forever, the graph would be continuing down here. And same to left. So no matter what value I picked for my x value, I would find a y value on the graph. So the domain is negative infinity to positive infinity, and so is the range. If you look to the right, we have a horizontal line where we could pick any possible x value and get a y value on our line. However, we only have one y value. So any possible x value, your domain is from negative infinity to positive infinity, but your range is only negative 2. Those are the only possible values if you were to look at the table of values here in your calculator. You can get 3, negative 2, 5, negative 2, 7, negative 2, 0, negative 2. So all the y values are negative 2. And the way that we show that we include that value is by putting solid brackets around that number. The better example is coming up next. Solid bracket. So here, and this graph should really have arrows. We could keep going to left and pick any negative x value we'd want, and we'd find a point on our graph for y. So negative infinity is our lowest x value. But now, as we go to the right, the highest x value on our graph is 2, and 2 is on our graph. So the way we show people that it's included in our graph is we put a solid or hard bracket there. And the range, this graph goes on forever. We could pick any negative x value and we'd find a higher y value or a lower y value. So the range is negative infinity to positive infinity. Now you have a circle. The domain and range are very specific. From negative 4, including negative 4, up to positive 4. There's your range. There's your domain, and here's your range. Now, the whole. We can see that this graph for x values or domain values go from 0 to infinity. However, we can't include 0, because if I were to make a graph, I could put 1 and I'd get a y value. It looks like it's negative 1. Or I could pick 3 and it looks like it's 0.5. But 0 is not on our graph. So the way we show that is we put a soft bracket or a parentheses next to it. That tells everybody 0 is not on our graph. 0 is not included. It's not part of the domain. Now, for the range is asking for the possible y values. The y values start at negative 3 and they go up to infinity. I'm recording. But we're not including negative 3 because there is a hole there. And I think the last example on this page, the domain could be everything except for this x value right here. What is that? It's like 2. My dogs are in an argument about going on a walk. Can you please get them out? I'm recording. So, from negative infinity up to, but not including 2. The way we show that is negative infinity to 2. And you always go from the lowest value to the highest value. Now we have a break on our graph because now we have the second part from 2 to, it's like infinity, going forever. So here's here. And the way we show that is we put a little U in between there. It says in union with. Now, let me erase all of that and show you the range. One of my dogs is protesting to walk. Okay. Range. The lowest value is 0, including 0, because look at that point. It's on our graph. And we can really just use these values right here. All those values are included. Now, yes, there is a hole, but at that y value, there is a point, and it's right there on our graph. So that y value is at 4, and there is a point on our graph that has a y value of 4. So that's why it goes from 0, including 0, up to infinity. All right, so we are going to move on to the graph of function. So the way we check to see whether the graph of, is a function is we use what's called the vertical line test. Basically, if you can create a vertical line anywhere and it crosses the line more than once, that is not a function. So not a function, boom, that's a function, boom, that's not a function. Now let's look at this one. This is a function because if I were to draw, you don't have to worry about the hole. I can't really draw a line there because there's no graph there. So if I read the definition here, a set of points in the xy plane is the graph of a function if and only if every vertical line intersects the graph at no more than one point. Okay, well there's no way to intersect a point at that vertical line. So let's look at this example. This is more like what you're going to be doing in your practice in your classwork next class. So f of 0, we're just going to read the graph. Well, when I plug in 0 for x, what do I get for y? 4. When I plug in 3 pi over 2, what do I get for y? 0. I'm going to change the color here. So, f of 3 pi over 2 for x, 0 for y. Okay. And 3 pi, when I plug in 3 pi for our value for x, that's our value for y on our graph, looks like negative 4. So what is the domain? The domain are all the x values. So the domain goes from 0 all the way up to, and it looks like it includes 0 and it includes 7 pi over 2. So we show we're going to include those values is a hard bracket, 0 to 7 pi over 2. And the range, I'll do that in green, goes from this lowest value, negative 4, up to and including positive 4. So we're going to include those values because they're on our graph. Now, the next question asks to list the intercepts, and they didn't say x-intercepts or y-intercepts, so I just went ahead and listed them all. You might have to press pause and make sure you understand that, but I'm going to keep going. All right, how often does the graph cross the line y equals 2? All right, so y equals 2 is right here. 1. Did I just erase the... change the graph by erasing. It's fine. Everything's fine. Just pull that on there. I'll use gray. Starting over this question, how often does the graph cross the line y equals 2? 1, 2, 3. 3 times. For what value of x does f of x equal negative 4? Alright, well, where does f of x equal negative 4? When I plug in x, y value is negative 4. Here and here. What are those x values? Pi and 3 pi. Don't worry about if you don't understand what pi or 3 pi means. Those are just the numbers that we're using on the number line there. They'll mean more later. For what values of x is f of x greater than 0? This is the hardest concept that pre-cal kids have trouble understanding every single year. This is asking, f of x is y, okay? Where is y, where are the y values greater than 0? So that is, let's see if I can find my highlighter. Okay, that is above the x-axis. Above the x-axis, that is where the graph has y values that are greater than 0. So we have to, I'm not going to be broken up there, we're going to have to break it up, but we know how to write that now. It looks like it starts at 0, and we're doing this in terms of x values, so domain. From 0 to pi over 2, because right at pi over 2, once the graph hits pi over 2, the graph goes below the x-axis. Now this says where the y value is greater than 0. So pi over 2, that y value is actually equal to 0. And we want greater than 0. So we're going to put a soft bracket around that. In union with where the graph goes below the x-axis, and here it's coming back up, so we need this part. From 3 pi over 2 to 5 pi over 2. So 3 pi over 2 to 5 pi over 2. Not including those values, because at those values, the y value is equal to 0. And we are being asked, where is y, where is f of x greater than 0, not greater than or equal to 0. You have to make sure you read the question. Okay, so we are almost finished. Example 3. In this point, so we're given a function here, v of t, and most of the time they use f of x, but sometimes you'll see, physics, you'll see other variables. So v of t. Is the point 1, 1/2 on the graph of v? Well, we're going to plug in 1 for x or t and see what we get for y or v. So we go ahead and we do that and we get 1/3. Well, that would mean that the graph, the point would be at 1, 1/3, and that is not what they're asking. Is the point 1, 1/2 on the graph? So no, it is not. B, if t equals -1, what is v of t? Okay, well, if I plug in -1, what do I get? Well, I get -1. So they're asking, what is the point? So the x coordinate, or t, is -1, and the y coordinate, or v of t, is also -1. So there's your answer. So this one they're asking for the point. This one they're asking, is it on the graph? And the last problem is, if v of t equals 2, what is t? All right, well, they're giving us essentially the y value. So v of t is 2. So what is t? Well, how do we solve this? We need to solve for t. We've got 2 t's. We just have to do some manipulating. This is one of the best parts of math right here. All right, we just have to make it work. All right. So the way I like to look at this is like a 2/1. And if I cross multiply here, that, okay, I'm going to get 2t plus 4. Where did I get that 4? Distributed. 2 times the quantity t plus 2. 2 times t plus 2 times 2. Don't forget to distribute. Equals t times 1, which is just t. So you solve it, and I just want to make sure I'm making no mistakes here. And you get t equals -4. It's okay if you want to pause and solve it, but I'm pretty sure you guys can solve a two-step equation. So we haven't answered the question yet. It's asking what is the point on the graph. So when t is -4, v of t is 2. There you go. There's your answer. All right, peace.